In order to understand and use the mid-segment trapezoid theorem, we need to make sure that we understand the trapezoid, what it is, and the parts of a trapezoid. So a trapezoid is a quadrilateral, four sides, polygon with four sides, with exactly one pair of parallel sides. So those sides are called the bases. So the parallel sides are called the bases. The non-parallel sides are known as the legs. So remember, bases are always the parallel sides, and look for those arrows. And here's two examples. Now, mid-segment, okay, just like we had the mid-segment of a triangle connected the midpoints of its legs, the triangle legs, the mid-segment of a trapezoid is going to connect the midpoints of the trapezoid legs. Okay, so right here is the midpoint of this leg, and it divides that leg into two congruent parts, the definition of midpoint, and here's the midpoint of this leg, which divides that leg into two congruent parts. And it doesn't have to be, a trapezoid doesn't have to have both of its legs congruent. So in this case, we're saying they're not, because even though these two pieces are congruent, they're not congruent to these pieces. So basically what this is saying is that one leg is longer or shorter than the other. But again, the segment that is connects the midpoints of the two legs of a trapezoid is called a mid-segment, and it will always be parallel to the bases. And so the mid-segment of a trapezoid theorem basically tells us that there's a special relationship between that mid-segment and the trapezoid's bases. So it could be said in a couple different ways, but the mid-segment of a trapezoid is equal to the sum of the bases divided by 2. Or you could say the mid-segment of a trapezoid is equal to 1/2 of the sum of the bases. And this is how you would write the formula for this theorem. So MS for mid-segment equals 1/2 times the sum of the bases, or the sum of the bases divided by 2. And now you're going to watch another video that's going to show examples of solving problems using this theorem.